Hello, Math 45 students. We're back again, and we're going to be talking about section 3.4, composition of functions. I'm your teacher, Cindy Enrique. So here we go. So for a composition of functions, we're just going to be doing several things to them. We're going to do addition, subtraction, multiplication, and division. So the first one is just going to be addition. The second one is going to be subtraction. And then the one below that is multiplication. And the one below that, the last one, is going to be division. And here it's just really important to notify or to notice that it's all about notation and what order it comes in. So for example, let's look at this example. We have function f of x, x minus 1, and our function g of x, which is x squared minus 1. So for part A, we have g minus f with respect to x. This is what it's saying. So I know I'm going to be subtracting the function, and whatever comes first is going to be written first. So this is really saying that g of x should be subtracted. So g of x minus f of x. So my g function, what I have is over here. That's x squared minus 1. So I'm going to have an x squared minus 1. And then don't be caught by this mistake. It's subtract the entire function. And that entire f of x function is my x minus 1. So remember, it's subtract the entire function. So now I'm going to have my x squared minus 1. If I distribute that negative, I have a negative x. And a negative times a negative is a positive 1. So I'm going to have x squared minus x minus 1 plus 1. So I know that g minus f with respect to x is going to give me x squared minus x. Since negative 1 plus 1 gives me 0. For part B, I have g being divided by f. So it's just a division problem. So up on top, I have my g function. Down at the bottom, I have my f function. So I'm just going to write it accordingly. So up on top, my g function, I still have x squared minus 1. That hasn't changed at all. And down at the bottom, my f function, that's the x minus the 1. I can actually simplify this further by factoring my numerator. Hopefully you see that this is a difference of squares. That means it's going to be factored by its conjugate pairs. So up in the numerator, I will have x plus 1 and x minus 1. And down at the bottom, I still have my x minus my 1. So what that tells us is that the x minus the 1 actually cancels out. So I'm left with an x plus 1 over 1. So I can say that g of x being divided by f of x is actually just x plus 1. Now for part C, I'm doing multiplication. So I'm going to have my f function being multiplied by my g function. So I know that my f function up above, it was defined as x minus 1. And it is going to get multiplied by my g function, and that g function is an x squared minus 1. Because that's so, what I need to do here is FOIL. So hopefully you remember foiling. That's first, outer, inner, last. So x times x squared, that's x3. X times a negative 1 is a negative x. Negative 1 times an x squared is a negative x squared. And a negative times a negative is a positive 1. So I'm going to get x3 minus x squared minus x plus 1. So I know that f times g with respect to x is equal to x3 minus x squared minus x plus 1. And so that's going to be my final answer. Notice how part D is very, very similar to part A. The only difference is the order. So just really pay attention between part A and part D. Part A, G went first, and part D, F comes first. So because the order is kind of switched around, I'm going to have to rewrite it in the same order. So this is really f of x minus my g of x. So I know my f function. I have that as x minus 1. And don't forget, when it's subtract the entire function, and that entire g function is my x squared minus 1. So when I write this out, I have x minus 1 minus x squared plus 1. So that's a negative, that's a positive. So I have a negative x squared, positive x, negative 1 plus 1. So I know that f minus g with respect to x is equal to a negative x squared plus x. And so that's going to be my final answer for that one. So for the next part, we're going to go down to the composition of functions. So for the composition of functions, it's kind of a function embedded inside of a function. So it's basically doing the function twice. So it's not fog, it's composition. It's f composed with g, okay? So that is what we say. So for example, we have, hey, given this, we are going to evaluate g f of 2. So we want to work from inside to the outside. So work inner to outer. Okay. So step 1. Find f of 2. So we say that f of 2, remember this is particularly saying that our x value is equal to 2 and we need to find the y value. So if that's the case, here's an x and here's y with respect to f. So that's the only thing that we're thinking about. So okay, so here's x is 2. So our corresponding y value then must be 3. So now I know that f of 2 is equal to 3. So now for step 2, we are going to input that value in. So what we just saw, we saw that g of f of 2 and g, well, the f of 2 that we figured out was 3. This inner part came from finding out what f of 2 was. So now here is our new problem. We need to find g of 3. So now we're going to be looking at our g function. So okay, so now look at x is equal to 3 in function that we call g. So okay, when I do that, I am going to get, well, here's 3 for the x function, and the g function is over here. This is my g function. So it looks like it's going to be equal to 5. So I can say that g of f of 2 is equal to 5. That's going to be my final answer. Part B is very similar, except the notation looks different, but that's okay. This is really saying f composed with g. So f is on the outside, so f stays on the outside. So the inside that we're going to try to figure out is g of 4. So we need to figure out that part first. So okay, g of 4. So we're looking at the function g, and we're looking at our x value of 4. So here's 4, and we're looking at the y value. Ooh, that's equal to 1. So now f, and what we have to input it in here is 1. So okay, so now I'm looking at my f function for when x is equal to 1. So when x is equal to 1, my f function happens to be a positive 9. So I'm going to say that f composed with g with respect to 4 is equal to a positive 9. That is going to be my final answer. So we saw the composition of functions with respect to tables. Now we're going to see the composition of functions with respect to a graph. So here my graph is here, so f is in blue and my g function's in red. Okay? And here it says find f g of 2. So I am trying to find f, and on the inside I have my g of 2. So since it's red, for g, I'll just go ahead and write it in red. So g of 2. So okay, so this is look at g function when x is equal to 2, find your y value. So okay, so g of 2, well here's my x value of 2, so that's right there. So that point is 2 comma negative 1. So I know when x is equal to 2 on that g function, that y value is a negative 1. So now I have f, and I figured out that inside is a negative 1. So, okay, here we go. Well, now this is telling me that I want to find when x is equal to negative 1, find my y value. So, okay, so here's my x, here's negative 1, and that blue function, if I go up, oh, it's right here. So that's negative 1 comma 3. So I can see that that y value is going to equal to a positive 3. So I can write my final answer saying that f composed with g of 2 is equal to a positive 3. That is how I'm going to find my answer. So let's see if we can do that one more time with part B. So, okay, here we go. We have f with g of negative 2. So, first part, I'm going to find g of negative 2 first. So, part 1. We're going to work on the inside. So, I have my x value at negative 2, and the g function is red. So, I want red right in there. So that value is negative 2 comma 0. So I know that's going to be 0. So now part 2, I need to find f of the thing that I just found, which was 0. So okay, when x is 0, my function f, which is blue, that's over here, I'm going to have my corresponding y value. So it looks like that's 0 comma negative 3. So now I know that f composed with g of negative 2 is equal to a negative 3. So we can do composition of functions. We did it with a table. We've done it with graphs. And now we're going to do it with equations. It's going to be the same thing. So we want to make sure that we understand that we work from inner to outer. Always work from inner to outer. So the inside here, we're going to have g of negative 3. Okay, so part 1, and we have our part 2, let's say. So the first part, we're going to be looking at that inside, which is g of negative 3. We need to compute that first. So, okay, so if I have g of x is equal to a negative x minus 2. Well, negative, and that value that I'm plugging in is going to be a negative 3. So I'm going to say that this is 3 minus 2, which is equal to a positive 1. So my g value is going to be a positive 1. So I'm going to take that value and I'm going to plug it in to my f function. So okay, so now what this is telling me in particular is I need to find f of that value that I just found, which was 1. So, okay, here we go. So my f of x is equal to a negative 6x minus 4. And that value that I'm plugging in is 1, since that's what I found from the first part. So I'm going to have a negative 6 minus 4. So that's going to give me a negative 10. So now I know that my final answer here is that I'm going to have that f of g of negative 3 is equal to a negative 10. And so that's going to be my final answer. Okay? Now, for part B, I have my functions below of f and g. I now want to find f of g of negative 2. So again, I want to work from inner to outer. So here we go. So the inside here, I know that I'm going to be working with g of x. So g of x is negative 3x minus 4. And in particular says that g of negative 2. So I'm going to have x is equal to a negative 2. So that's what I'm going to be plugging in. So we have a negative 3 minus 4. And that value I'm plugging in is a negative 2. So this is going to give me positive 6 minus 4, which is going to give me a positive 2. So now I need to plug that into my f function. So f function, I know that's an x plus 6 over x. And what I'm plugging in is that x is equal to 2 now. Let's have that in a different color. So we know from x is equal to 2 from part 1. So you don't know what value you're going to plug in until you actually compute part 1 of this equation. So now I know I'm going to have x plus 6 over x. And that value that I'm plugging in is 2. So I'm going to have that this is 8 over 2, which is 4. So my answer, I'm going to have that f of g of negative 2 is equal to a positive 4. And so that's going to be my final answer for that one. I hope this is making sense to you guys. And if it isn't, make sure to email me and we can do a Zoom conference where we talk one-on-one together, or you can just send me an email as well. So on page 17, we now have the difference quotient. So the difference quotient is very important. And when I say very important, that probably means it's going to be on the next exam, okay? This is kind of like the beginning of calculus. So what this tells us is the secant line between the points. And you're like, what the heck is a secant line? It's something that happens once you're looking at calculus, but that's okay. So here we know the formula for a difference quotient. We have f of x plus h minus f of x all divided by h. So that x plus h is actually what you're plugging into x. I know that sounds weird, but that's what you're plugging into, okay? So for example, I have, hey, find the difference quotient for the following equation. F of x is equal to x plus 9. So this is going to feel really weird, but just go with it. You want to figure out what f of x plus h is going to look like. That means every time you see this x value right in here, you're going to be substituting in x plus h. So x plus 9. So the thing that you are actually writing on the inside is this x plus h. So x plus h. So this is really x plus h plus 9. Okay, that is what that looks like. So when I have this equation of f of x plus h minus, and I like to put brackets, f of x, all being divided by h. So now I know exactly what this is going to be looking like. Well, the first part I already have. I already calculated over to the side. So I know what f of x plus h is. That's over here. So I have x plus h plus 9. Now I have minus my entire f function. So my original function of f was x plus 9. And it's going to all be divided by h. So to simplify that even further, I have x plus h plus 9 minus x minus 9, since I distributed the negative on the inside, all being divided by h. So what we can see here are things are going to start to cancel out. So what cancels out is this x and that negative x, this positive 9 and that negative 9. So what I end up with is h divided by h. And anything divided by itself is always going to be equal to 1. So that's going to be my final answer for that one. Now, x squared minus 2x minus 3. This is going to be a bit more involved because my equation is a little bit bigger, but it's still the same principle. So over to the side, I just like to kind of do my scratch trick over to the side to make it a little bit easier for myself. So I know that I have f of x plus h. That's going to give me x plus h squared minus 2 x plus h minus 3. So this is really x plus h times x plus h. And if I go ahead and distribute, it's a negative 2x and a negative 2h minus 3. If I were to FOIL that out, I'm going to get an x squared plus xh plus xh plus h squared minus 2x minus 2h minus 3. And to make it a little bit easier, I can actually go ahead and add those two values together. Xh plus xh tells me that there's 2xh plus h squared minus 2x minus 2h minus 3. So now when I rewrite this equation, I know I'm going to be following that general format. So now I have f of x plus h. I know exactly what that looks like. I have x squared plus 2xh plus h squared minus 2x minus 2h minus 3. And it's subtract all of my original function f of x, which is an x squared minus 2x minus 3. And this is all being divided by h. Oops, sorry there, guys. So when I combine like terms, I'm still going to have my still getting used to this touch screen. So I have x squared plus 2xh plus h squared minus 2x minus 2h minus 3. And because I'm going to distribute that negative on the inside, I'm going to have a negative x squared, a positive 2x, and a positive 3. And over here, I'm just going to say it's all being divided by h. So what I can see, some things are going to be canceling out. I know that this x squared cancels out with that negative x squared. I see a positive 2x and a negative 2x. And I see a negative 3 and a positive 3. So all of that f of x that was in my original equation ended up canceling it out. So now I'm going to have what's left over. I have 2xh plus h squared minus 2h. And everything's being divided by h. Don't let that confuse you. That means each thing is being divided by h. So 2xh divided by h plus h squared over h minus 2h over h. So I actually have 3 mini fractions. So what ends up happening, those h's cancel, that h cancels, and one h from the top and one h from the bottom cancels. So I'm going to have a 2x plus h plus 2 as my final answer. Again, this problem, it was long, but it's doable, okay? You guys are perfectly capable of doing this problem. You just have to make sure that you keep track of everything that you're doing and you really understand that general formula for the quotient formula, okay? So the difference quotient is just f of x plus h minus f of x all being divided by h. So when everything is being divided by h, you want to make sure that each thing that's separated by addition and subtraction is divided by h. And that is the end of section 3.4.